All right, hello everyone. Um, Let me prep here so we can get going. Yeah, so I've been working on my personal website for a bit. We're still gonna talk about Notion. We're still gonna talk about this fun stuff, but I just thought to share this with you. If you have any feedback, please provide it. I was kind of like, I haven't really finished it yet, so I still have to finish the hovering effect and actually read the articles. So I decided that I'm gonna do it with like static until it grows a bit than I do for server. But if I do it static, I can pay $0 and have it hosted. I currently have one with Wix, but and it's nice. Like it provides so many features. I don't really use even quarter of them, so I don't really care that much. But I wanna build it. Also, building shit is fun, honestly. Like doing it and like doing the whole like responsive thing and making it look pretty is I don't know. I used to hate CSS for like the longest part of my life. And now I don't think I hate it as much, you know. I don't love it, but I don't hate it as much. I'm gonna go for I'll put you on hold here to double check that the volume and everything is working properly, because I don't want to spend an hour without music for you guys or without my actual voice. So be right back. All right, looks like everything is fine. So we can get back to our regular planning. Give me a sec. All right, so now we can actually get started. So first things first, let me have you all here. And let me close a bunch of stuff. Great. Oh, look at that. Fancy. Wow. Just pictures of me everywhere. Damn. All right, so last time we talked a bit about Docker Compose, and we had our Compose containers running, Neo4j, and I showed you how we can do that. And what else did we do? And we also mounted it with a volume and everything. So that was the Docker file that we did. Sorry, the Docker Compose file that we did. So now if we visit like localhost 7474, we had our local instance of Neo4j, and it's cached in my browser. So if we did like match the document and we return the D, there you go. Great. So last time we went into a very long rabbit hole of trying to use the driver for Neo4j, and we were implementing the save document, and we ran into a bunch of issues, but we got it done, right? But we also learned shit ton about how to use it. So let's summarize what we learned, then we get back into cleaning this up a bit. So for me, I want to clean this up a bit. Then I want to move forward to implementing maybe some of the other features. Specifically, we ignored here the user ID, and I'd rather have it from context, and we'll talk about how to share that through context. And I also want to create the repository as a singleton. So we'll start talking a bit about design patterns. I'm not going to get a whole lot into design patterns, but I'll give you what a singleton is. We'll talk about good resources to learn from them. I'll show you how I learned them, and yeah, we'll go from there. So that's kind of like the gist of what I want to do. Also, I got this new mug here, so hopefully it doesn't burn my tongue, but yeah, first try, so cool. All right, so what did we learn about the driver, right? So we created our URI, username, and a password, and that will be used for our authentication mechanism. So when you create a driver, you say Neo4j, new driver with context, right? And then this would create a driver for you, and you have to pass it the URI, so where to connect, and your authentication mechanism. One way to authenticate is the basic auth, which is essentially a username and password. And right now we have these hard coded here. We will fix this right now after we discuss what we have so far. Then we check for errors. If there's any authentication errors, we hopefully get them. Then we create a context in the background. And there's a lot to say about creating a context. So skip this for now. Let's finish our stream of thought, and then we'll get back to it. Okay, so you've created a driver. Once you have a driver, you want to create a session, right? And a session is what's gonna hold the transactions. So we created a session. So you pass a context and a session config, and then you can start executing writes and reads. Something to note though is that we're using the Neo4j execute write. These are the generic version of the execute read and execute write, since Go introduced the generics, so you can use generics in Go now. And this method essentially allows you to do it the generic way. So you give it a context, you give it the session that you just created, and then you pass in a callback for a managed transaction. You can manage your own transaction yourself, but this way it's managed for you, right? So you don't have to commit it and you don't have to abort it. But we might get into more complex situations where we need to manage the transaction ourselves, right? And we will probably get to that. I don't know when, because I honestly don't pre-plan these. I just kind of like get into it and jump into building with you all. So when we need it, we'll get to it. All right, and then you write your Cypher query. And here we're saying that we're gonna use a merge. And why are we using a merge? Because if we have the same data with the same properties, I don't want to execute anything, right? I don't want it to duplicate data. If I use create, it will duplicate it. But if I'm using merge, it will say, it will do like select, okay, if it matches, then ignore it. If it doesn't, then update it. And I showed that on last stream. Okay, then you start by saying, I want to run this transaction. And the driver allows you for a very cool feature here, which is you can pass variable in your query, and then you pass it like a key value pair when you're doing a transaction run. So we're saying transaction.run, passing the context, passing our cipher, and then giving it a map where anytime it will see a dollar sign, it will look for that same variable in the map, right? So that's great here. And once that runs, we will check if there is any errors, right? So now we got stuck after doing that. So we're able to get it there. And then last time it took us some time to find the single T with context, right? So there is a bunch of methods in order to like getting the data back. So if you do like Neo4j, you have single, you have they're usually called collect methods. So yeah, you have collect T with context, and there's just collect with context. So that's the generic version of this, right? Okay, so now we know that we're only going to create a single node, so we want a single node back. And we're saying that this single node that we want to get back is of type document. So you pass it the context, you pass it the result, and then you pass another callback. And in this callback, you're getting a Neo4j record, right? And you can think of a record as like a record in SQL, or like a row of data essentially, where here you can start asking for saying give me column which is named like username, and it will return that for you. So how are we using it here? So we're saying Neo4j get record value. So from that record, I want to get the record value, and I want to extract a key called D, right? So why are we extracting D? Okay, let's go and look into our cipher. So here we're giving a variable D for the document, and we're returning it. So that's why you're saying my key here identifies the node as D. Because remember, in cipher, you can return multiple things. And since they are named, you can reference them directly. Okay, and then we printed the ID and the name for that document. Okay, so here we're also returning an empty document, which is not the right thing to do. Also, provided that like the method already takes a document in, you don't want to change the document that's being returned, essentially, right? Also, the saved document really returns just an error, so we don't care about the document that you're gonna get back, because the saved document, if it doesn't fail, the client already provided the document that he wants to create. So why return it and recreate it? Okay, so that's something that we want to change. Because here, we don't really care what is being returned. Okay, we'll fix that, but let's continue. So here we have the node ID and the node name, and you can access them straight from the props, which is really cool, because if I go here, here's the ID, here's the name, and it's essentially a map, right? And we didn't really get into how to use these things because you need to verify their type. Since it's not needed, I'm not gonna get into it right now, but when we do get document, this will become very prominent and we'll have to do it anyways. Okay, then we check for error. If there is, we return an empty document on the error, and then we return a document and a nil. And again, we check for error. If error is not nil, we supposed to return the error, and otherwise we return nil. So a Neo4j session, Neo4j transaction, and the cipher with arguments, all of that has been done. And we kind of executed a manual test for that, right? And we wrote here like repository, new Neo4j repository, then we created a new document, then we saved the document, but we didn't try to get it back in order to like verify if it's actually already saved or not. Also, remember that this is an integration test, right? So you've got a couple of options here. One is that you can say like repository dot get document by ID, and you give it the document ID that you shared. So for that case, would be like doc.id, right? And you say what? And then you can say, actually, we can do that. You know what? That's fine. So typically, we use that here. Okay. So if font is not equal got, then we return an error, right? And what we can do is we can say compare the equal font got pero font got. Actually, we can even do better. We can do compare the diff font got. So what am I doing here? So you want to verify that the document that you saved is actually saved. So we're saying, okay, well, I'm gonna save it, then try to go get it from the database, and if both of them matches, if the one that I got from the database is same as the one I saved, then I successfully saved it. If not, then something has went wrong. But here, I'm coupling the test of the saved document with the get document, right? So if someone makes a changes to how saved document works, or even, no, vice versa. If someone makes a change to the get document method, and there's an error now, the saved document might just fail, right? So that coupling isn't always the best. It's acceptable, don't get me wrong. We can probably do this way. But the other option is that you write the Neo4j code that we just wrote for kind of like get document into here, asking it to return the content for you, right? I'm gonna opt in for this right here, and this indeed will fail because get document right now only panic, right? But let's see the panic, then I'll return something useless, then we can fix these. So we're gonna go to the bounded context, documents, repository. Awesome. Go test with the tags integration, and we're running the save document test. So now we should see a panic that says implement me. That's well, yeah. All right, let's see. One variable, assignment mismatch variable, but people get document by ID returns two values, right? So our test code is actually not correct. And so get document by ID returns a document and an error. And why is that complaining about? Well, I guess we're good. Right, so doc ID here is of type ID, and it is saying that you cannot use it as a type of string. So we're gonna say doc.id, which then we can, since doc ID actually is an underlying type of a string. Bingo. So it says panic implement me. Okay, so let's remove that for now just to fake it, and we're gonna return documents. We're just gonna return an empty document and nil. Great. Okay, so that already shows that we have something that is not correct, right? We're saying compare dot equal, right? We actually want to say if they are different, then fail. So now we should fail. And here it shows that you're missing the ID, and it shows that you're missing the name, right? I don't know if I ever talked about this compare package. It is written by Google and it's very helpful. So compare, GoLang, compare. So yeah, so this package is intended to be a more powerful and safer alternative for reflect deep equal for comparing whether two values are semantically equal, right? So the idea is simple. It's like you have a struct, for example, or two arrays, and you want to compare if the values are equal or not. You can use compare.equal, right? One thing to keep in mind, if compare.equal would only work on exported fields, right? So if you have any internal fields, it actually might panic. So watch out for that. Great. Okay, so our test successfully failed now. And that's good because we haven't implemented the get document, right? But before we get into implementing the get document, let's refactor the save document for now. That's our first thing that we need to do. Okay, first things first, the URI, username, and password. Is that relevant only to the save document? Not quite. So I can go and say the Neo4j repository has a username, which is a string, as a password, which is string, and a URI string. Great. So that's the first step, and I can delete that. This doesn't have to be here. Okay, so that was our very first refactor. 2, when you create a driver with context, right? Let's read the documentation for that one. So if I click, well, actually, let's do it how pros do it. So go packages, right? And you can search for Neo4j. And here you go to V5, and we can search for new driver with context. So let's read this here. So new driver with context is the entry point to the Neo4j driver to create an instance of a driver. It is the first function to be called in order to establish connection to Neo4j database. It requires bold URI and authentication parameters, and can also take optional configuration functions as variadic parameters, right? They call that functional configuration pattern. So no connectivity happens when the new driver with context is called. Call driver with context, verify, connect once the driver is created if you want to eagerly check that the provided URI and credentials are correct. So, oh my god, about 2 streams ago, I was using a cloud version of Neo4j, and I had a stale URI that I was using. And because I didn't really read through the documentation, I was just kind of like doing it based on like me doing it before. I didn't know about the verify connectivity. So I created the driver, and we banged our head trying to figure out what was going wrong, and it's literally right there. So it's a lesson that I've come across so many times, so always remember it. Always try to check the documentation, especially of like a library. Spend some time trying to read it before actually just going on and using it, right? And that's a lesson for me as well. And I tend to do that, but yeah, that happened. So, all right. So we have, here is a mental note for us to add the verify connectivity, right? But we also, they said here that you don't actually connect when you run the method new driver with context. So in order to connect to a single instance database, you need to pass a URI with a schema. Great. If we have casual cluster, you'll have to pass the Neo4j, Neo4js. We will discuss casual clustering much later, so that can wait. You can configure options by providing configurations functions. Yeah. The authentication can be nil. Great, okay, that's all fine. Okay, so what I was mostly looking for is that the new driver with context doesn't actually connect right away, right? That's the information that I was trying to prove or get to. And why is that important? Because if that's the case, I can simply move these to the actual creation of the Neo4j repo, right? But before we do that, I'm trying to understand where does the context here comes in, right? So it returns the driver with context, which is a driver here that I'm assuming, of course, has a context, and this context right here. Oh, I see. So you're forcing yourself to use the session with context, and you verify connectivity with context. So it's saying, I will provide the context for you to use it. Okay, understood. Thank you. So now we can say here, you know what? Actually, I do have a driver, and it's gonna be a Neo4j. Neo4j dot driver with context. All right. So all of that now can be gone. And here I can say neo4j.driver.new session, right? Of course, this is not gonna work properly because right now nothing has established that basic auth. And this is something that's super cool about tests. So let's run our test and see what will happen, right? Because when you're refactoring, when you have a test, at least it helps you. So now we're gonna get a null pointer exception, right? Invalid memory address or null pointer dereference. So you actually got that not even from, well, yeah, no, this is the first time we're causing m.driver. So you're trying to say, hey, driver, give me a new session, but your driver is actually nil. So when we're creating the new Neo4j repository, we can do the URI, we can do the password, and we can do the driver. Okay, so I know it was localhost, but that's the beauty of Git. Give me all of that. I don't care about none of that. Great. Username, password, and now the driver function, which is neo4j dot new driver with context, right? And we pass the URI. Right, so we can't really do it this way, but give me a second. So if let's just do something for now. What if I do this? Well, actually, I can't really even do this right now. So here's what we gotta do. You want to create a driver, an error, okay. So we're gonna say a repo. Here's my repo. Return me a repo. Magnificent. So now auth j basic auth, and we say repo dot username, repo dot password, and we don't really care about the realm for now, and we can say repo dot URI, and if error is not nil, and that already shows that the new repo should also return an error. Fun. So now our code is actually getting cleaner. Want to return nil and the error, and here we're gonna return the repo and nil. Or you can do that. This is better to make sure that, like, if the user is one of those types that would skip the errors, they will get a null pointer exception, or like dereference in that case, which is good because you kind of like ensure that they do check the error. But if you don't want them to have like, you want to give them the freedom to do it either way, we can just like return an instance of the repo, which is this one, and the error, right? I will let's see. Am I allowed to create a repository if it fails? The answer is no, right? So I'm gonna opt in for the more stricter option, which is like, if you have an error, I'm gonna return the nil to you, right? Otherwise, I'm gonna return the repo and a null. I can also do this because here you're guaranteed that error is nil, but code is for readability, so here you have it. So now you can also say repo.driver is equal to the driver, right? So that's one way of doing that, of course, only if it succeeds. Now I'm questioning my decision about having the username and password as part of the repository, right? Is that something that is really part of the repository, or is that configuration? So a username and password might change at any time, right? Let's say, yeah, the infra team or like the security team says we're changing the username and password, and because of that, you have to either like reload your app or implement hot reload, right? And the concept of hot reload is fairly simple. It's like, okay, now you're gonna say to the driver, hey, my driver instance, get the new username and password, right? And well, right now it's all hard coded, so you can't do much with it, but soon enough we'll do configuration through like OS environment variable. Then we're going to get into Viper, and Viper allows you to do hot reload, right? So you don't have to implement it yourself from scratch. But now you need to be able to tell the repository, hey, username and password has changed. So that's what I'm trying to consider right now. So yeah, so the repository here should be fairly oblivious about how the username and password comes in, right? For it, as long as it's able to retrieve it, and that's like an implementation detail, then it's fine. Okay, I'm getting ahead over myself with hot reload and all that shenanigans. This is fine for now. So now let's rerun the same test again. And now what we're having. Right, we're getting an error because we changed the way the Neo4j repository is working, right? So here we also return an error, and we're not really doing. So here you go. Where is this failing? Neo4j repository line 15. Yep. So okay, we're good. We're back to where we at. So our refactoring is going well. All right, goodbye. Let's see. Should I talk about context right now, or should I get into the session stuff? So the session would have to be established from within each method. And the reason being is like each method should have its own context, right? So if I'm saving a document and I'm concurrently getting a document, we're not sharing a context. That context is being specified at the point of run, which is executing that method, which is like save document. So now when we look into the session right here, we must do it. We should do it this way then, so we can pass in the context that we want to pass. Or okay, the reason why I also don't want to share a session, right? Because maybe the context thing is not valid. Maybe you want to say, I'm gonna provide the default like 500 milliseconds is gonna be my context expiry, or like my timeout. And then for the execute, right, you can extend whatever context that is, right? And your argument might be like, okay, we can say, why not have the context as part of the Neo4j repo? And there's a lot of like hot debates about how you handle the context in that sense. Let me actually try to find out. So Dave had written one about context that was very, very good. Context isn't for cancellation, right? So there is his arguments here. I don't know. Should we read it together? Or yeah, you know what? You all like, I've been getting a lot of good feedback about this, and I'm really loving that you all are enjoying this. As you can see, we're like doing things really together, where I try to hold the urge of working on this behind the scenes because I want to get that shock value of the things that I don't know right on the stream, so it feels more natural into like how we all hit walls and how we all overcome things in code. So for me, it's kind of really important to get that kind of feedback from you. Would you like me to start reading articles as well midstream, where we learn about a topic more in depth, right? Than just like what we need to continue. Hi, Marcel. So yeah, let me know if that's something will be interesting or not. But anyway, this article here is really worth reading. And his argument, as I understood it, is that context isn't really for cancellation, right? So yeah, that's all I'm gonna say about that. Go read it, or if you want me to read these things on live stream, let me know and we will do it next time. Okay, so now we have the session with a context. And now what? Okay, so we have the session. We'll move over from the session for now and get back to it when we need to. We have the execute write, and it takes our context, takes our session, and the manage transaction. Okay, now in the manage transaction, I'm saying I'm gonna return a document and an error, but I don't really need the document, right? Because I'm only returning an error, and that's if anything were to happen. I'm just gonna say any and error, but now I don't really need to return this at all, right? I can just return the null. Also, I'm collecting the node, but I'm not really doing anything with it, right? So for me, well, I guess we need to check the result. So we need to collect it, and if there's an error, we'll return it. So here, oh, sorry, we don't really need this. So we just need to make sure that the node is actually being returned. And here, the get record value, you get a record, you get a boolean, and an error. I'm just interested in the error. Right? And single with context here, again. It cannot really infer. Well, my bad. You can remove the type from here, and here you can say any, and you're returning it. And really what we're checking for is that if you get any errors here, it will return to this function, and this function is within the single T with context, so that will be our error from that callback, which then should returns nil and error. We're not interested in the documents whatsoever, so now I can actually just say return nil an error if there's any. Okay, wonderful. This all is happening here, and now I'll just simply check is there's an error from the execute, right? But I don't even need really to check, because guess what? That's the only thing we will be returning. Now, let's run our tests and see. All right, we definitely fucked something up. So let's see. Interface conversion, nil. Okay, so it's complaining that we're returning a nil for something here. Let's see. right? So what about if we do, let's find the return null, and we return an empty string, for example. With this satisfied, it would. Okay, so why this happened, right? Because you're returning any, so it has to be a type that satisfies the any, which is an empty interface, and null doesn't satisfy that, right? Okay, so now our saved document is much cleaner. Great. Let me now do this thing where I show you the before or after of this here, right here. Show diff. So that was all the code for saved document, and now you can pretty much see it in like one box. Much better. Great. Okay. Now let's go clean some of the tests before we talk about the singletons. So now testing Neo4j new repo, right? Oh, all right. I did not mean to do that. Great. This test is shit. Why? Because, well, actually, we don't use that here because in the very first stream we said that things are gonna happen incrementally, so we don't judge the code as is. Great. So this code is bad. All right. Why is it bad? Because here we're only creating the repository and we're checking if there's an error, and that's really about it, right? We're really here checking that like an empty repository is exactly what we get, right? So that is not great. And this test, actually, let's run this test. So now, wow, we got all sort of things, right? Cannot handle unexported field, repository, the URI, right? Yeah, of course. And that's what I was saying about the compare package. It cannot compare something that is not exported. So URI, username, and password. And am I willing to export it for the sake of using the compare package? No. But also, is the purpose of my test is to know that Neo4j repository, the new Neo4j repository, returns me a valid repository, or am I trying to validate that the username and password are correct, right? So what I'm really trying to do is to check that I do get an instance of the Neo4j repository and not really interested into the username and password. And really for all what I care about is that I can execute things on it. So for me, Neo4j repository, there is nothing much to test except that I want a singleton. Okay, so this test is now completely invalid. What are we trying to test, right? Is it a singleton, right? Yeah, I guess that is kind of what we're trying to test here. So what is a singleton, right? A singleton is simply saying that every time I call this method, I will get the same instance, right? Rather than creating a new one every time. So let me show you what I mean. So here, Here's one. Neo4j repository dot new Neo4j repository and want and got. Right. And now, but I'm gonna compare the addresses different instances of the repo. All right, let's run this and see what happens. And of course, I'm gonna ignore the error for now. And it's still trying to compare these, so I'm just comparing like two ints essentially. Right, so different instances. And let me print. You see how A880 and here A8C0. So these are like different instances, truly different instances, right? So you might start wanting to say, what's the benefit of having a singleton, right? Well, the idea of a singleton is like at any point in your code, you're ensured there's only one instance of that repository. Why is that important? Because many areas of your code will be using the repo, and when they are, you want to ensure consistency. So for example, if the username and password actually do change, you want that instance to change once, and anything that's using it has just continue using it with the updates. So you want the updates to reflect everywhere else. And there is really no point of including multiple instances of the repo for really no reason, right? So why did I choose to talk about singletons now? Because it's a very common pattern in repositories in general. Few things. Well, let's implement our very first part of the singleton, show you the mistake, refactor it, show you a couple of resources that I think you're all gonna like. Okay, so how do we create a singleton? So you can say, here's a var, and this is gonna be our repo, and this is gonna be of type Neo4j repo. Pointer to Neo4j repo here, and we're gonna check if Neo4j repo is equal to null. Well, actually, is not equal to null. Return Neo4j repo. Right? Otherwise, you say Neo4j repo buddy is equal to and you return the Neo4j repo. All right, so let's run this first and let's see. Hold up. So it did return the same instance right here, but the test is failing. So that tells me that something is wrong with our test, right? Neo4j repository already returns a pointer, so let's see. Right, and here let me skip this part. Great. Okay, so now we hypothetically implemented our repository. It's as simple as that, right? You have a package variable that is only accessible within the package, and you can say every time someone calls the Neo4j repository, you check if it already exists. If it does, you return the same instance. If it doesn't, you create a brand new instance and you return it for them, right? And typically there is a function called get_instance in repositories in general that you can say return a Neo4j repo, and it wouldn't really return an error in that sense, right? And you're gonna say here so typically when you have a repo, you don't really use the Neo4j repository. You use get repository, and that returns the instance for you. Another way is that you can do what I just deleted here, which is the get instance, and you return the repo, and you just do the same check, right? So if Neo4j repo is not nil, you return the repo. Otherwise, you say Neo4j, you create a new instance, right? And you say if error is not nil, we'll handle it. Then you say Neo4j repo is equal the instance, and you return the Neo4j repo, right? Also, I discovered that using this Neo4j repo word will be confusing in explaining things because we're also working in the Neo4j repo. So time to rename this to instance. Great. And now here, bam, bam. So that gets a bit cleaner to talk about. So we have an instance, and if that instance doesn't exist, if it exists, so it's not empty, we return a new instance. We return the instance that currently exists. If it is empty, we create a new repository and we assign that repo to the instance, and we return our instance. And the simplified version of it is the get instance, which will just return the Neo4j repo straight, and it does ignore the error in that case, right? And why we're doing it this way, because in the initialization phase we will run Neo4j repository, and after that, for hot reload, we're not gonna run a new. We're gonna do certain ways where we can override the defaults of the instance. Right, so now I can go and say new Neo4j repository, all of that. Let's see, is it the same? Great. And now if I also do get instance, would it still be the same? right? But now I'm trying to compare two, but I only get one. Same thing. So we've already seen that the creating a new instance, but I actually opt in for the get instance, because that's kind of like what we're really trying to work on here. And bam, it passes, right? But now there is still a potential for an issue, right? I'm going to create from this sync package. There is something called wait groups, and I'm gonna create a wait group. And then I'm gonna create. I'm gonna explain everything I'm trying to do right here. Let me just write it down because I'm not even sure exactly how I'm gonna give that as an example. Sure, yeah, we can keep it like that. That's fine. Well, repository. Okay, instance. Actually, for J, yeah, repository. Okay, instance. Remind me to do something here, because now we're using this as part of the repository package and we're not really linking it to Neo4j, and you will have an instance of your mock, right? So here, rather than saying get instance, you can say get Neo4j instance, and that way it's more specific what exactly are we trying to get. And now, caught. All right. Let's see if that works. Right. Pointers. Too many arguments in call wait group dot wait. Right. One second. GoLang test no cache. Or wait, why is it? I know I went a bit rogue without specifying exactly what I'm doing. Right now, I will get to explain this in 1 second, so bear with me. And another thing that I'm gonna get at is like I'm looking at, there's the go test. I had it before, where you can specify. Oh, okay. I guess it's count 100. Great. Ha. Sorry. I just had to. Okay. So let's explain what's happening, and I'll explain why this is a success. So right now, where we're saying if instance isn't nil, return an instance, right? And then if it is nil, we call the neo4j new repo, which will also check for the instance, right? And by the way, this is so unnecessary because now you shouldn't be calling the new neo4j repository, you should be calling the get instance. I'm just leaving it here as a safeguard, right? If someone misuses it, because we tend to use the new, then they're still getting the same functionality. But the point is, when you're here, so you're saying, okay, instance is still nil, so I'm gonna go and create one. And of course, instance is still nil, so you're gonna go and actually create it, run the driver, yada yada, and then you'll assign the instance, right? But we didn't account for concurrently running code. And what if you go and you say one Go routine is saying, okay, I'm gonna run, and it runs here, then goes, stops it, so now it sees instance as nil. The other one goes, it says instance as nil, and it starts creating the repo. It creates the repo, but it doesn't finish yet, right? Meaning that it actually maybe stops here. So it adds, for example, the driver, but it hasn't finished that line of code that assigns the instance to the repo. And if that happens, now you go back to the first one, and the first one is here. It goes to the neo4j repo, it follows the same things, it creates a new instance, and now you have two instances, right? So this is a bit difficult to test. So how do you test for that, right? So the way I did it is like, okay, I'm gonna create two Go routines, right? So you can think about it as like either they're gonna run asynchronously or that they're gonna run in parallel. We don't know. It depends on your operating system, and it depends on your like how many CPUs you have, the load, and how the Go runtime decides to run it. But the thing is, we don't know if it's running asynchronously or if it's running in parallel. And because of that, we sometimes will have it run this first, then this second. Sometimes this will finish first and this will finish second. But then the problem happens when you run into a situation where this didn't finish, and both of them get a new instance. Okay, so what did I do here? So we have the concept of wait groups, and wait groups is essentially a counter, right? So it's a counter that says I need to reach a certain number before I'm able to unblock. So I create a Go routine and it says, hey, wait group, I'm a Go routine, please add me to your list. So my count increments, right? Then for the other one, same thing. Hey, Go routine, please add me in your list. So now my Go routine only knows I have two concurrent operations that are gonna be running. Now, when they run, they're gonna do something, which is get the instance, and then once they get the instance, eventually, once it's done, it will say, hey, I'm done, take me off the list. And same for the second one as well. And then we say, because these will run actually after we finish like getting here, right? So the wait group.wait blocks, and it says, I'm gonna wait till my counter is back to 0, and when it's back to 0, I will let you continue execution, right? Yes, that's the code for it. I actually don't fully understand the code. I've never tried to read this code before. we will potentially do that. But essentially, even here it says counter 0, no need to wait. So the conceptual explanation is fairly correct. Okay, so why did I celebrate seeing this one? Because when you're programming anything concurrently, it is known that like when you're trying to test for something to fail, it's very hard to get it to fail. And it will only fail in the most inconvenient time, right? I'm not gonna act like I've built highly concurrent systems all the time. That's not what I do, but I'm aware of the problems here. And one of these problems, as I mentioned, is like you cannot guarantee which one would run in which order. And that's the beauty of concurrency, really. That's actually what makes it fun, but also what makes it extremely damn difficult. So that's why I celebrated, because 1 out of the 100 failed, right? And the way I did this is I passed the count flag and 100, and I said, hey, go run this 100 times, right? Let's say actually if I run it 1,000 times, what happens? It didn't really tell me how many failed. It just says that there's a failure, right? So anyways, when you increase the number of runs, you potentially increase the chances, but it's not even really guaranteed, right? So let me do this, right? So if you only run it once, you'll be like, oh, everything goes, I'm fine, but that is not true. Okay. So how do we fix this? Well, common pattern to use is that you use something called a mutex. So you say in the sync package as well. So you can say bar mutex is equal sync mutex, or you can even like call it lock. Typically people call it that, and let's see why it's complaining, because there's no used, of course. So now when you're in the get instance, you can say lock. And by the way, if you just do this and you never unlock it, you have deadlocked your code, and it will keep hanging forever because you have this lock that never releases, right? So the way to do that is you say lock dot unlock before you return the instance. And now run it 100 times. We should be fairly okay, except that we're still getting an issue where it's hanging now, right? We'll give it some time till it times out, and maybe it will tell us why it's hanging. Also, okay, so this won't time out, so we're potentially hit a deadlock here. So let's see. Actually, is there, let's see, sync bar act equals sync dot. Yeah, there it is, that mutex. You can say lock. Oh, dang. You see, that's what it gets even tricky, because you see this return here. If you don't unlock here, then you are screwed. And that's where, drumroll please, the defer keywords comes in. So rather than me having to think of like, oh, every return include an unlock, good go says, oh, okay, you can defer. We will run that, the last thing for you right before the return. So now, out of the 100, okay, this has ran, but still something is wrong, right? Let's see. Different instance of the repo. Okay. Right. And the problem here as well is that we're trying to write to the instance variable from multiple places. That's no go, right? So here you actually return the repo. That's what the new is for. It shouldn't care about the instance. Now, okay, we're still failing. We'll get to the bottom of it. By the way, that 0x0 is typically referring to you returning nil, right? So when do we return nil? Actually, if there is an error. So error nil. Let's panic. All right. You know, it wouldn't be a fun stream without like a strange, suspenseful bug. Right. So where do we want to lock the instance? That's where what we have to think about, right? So lock the per lock dot unlock. So if the instance is not nil, we're gonna return the instance. Otherwise, repo. So this operation is what I want to be atomic. And bam. Did you see what just happened, right? One ran to successful, the second wasn't. Let's debug the code. Great. We create a repository, we create a driver. If error is not nil, we return nil, then we return the error. And we are seeing the 0x0, which is typically referring to nil. And then here, if everything passes, the error itself is nil. So the question is why when does it error, it doesn't panic? Because we should see that panic. So one Go routine will go ask, hey instance, are you nil? It says no, I'm not nil. Then okay, returns the instance. Or it says, yeah, actually I'm nil. So it says, okay, well, let me lock you right here. The rest you're gonna execute as one unit. So it goes to the repository. Hey, give me a new repo. Great, so the repo should be fairly returned okay. If something happens, it would return an error. And then if nothing happens, it will say, hey, instance, I will assign you to that repo. And lock.unlock. Okay. I'm trying to see why the error didn't really panic, because I'm assuming that's the only way we can get nil. Except if I'm not looking close enough. Okay, 1 second. Let's run 1000 times. Same thing. Except now, of course, I'm only not getting any useful information, right, that I want. Great. Different instances of repo. Why are we returning nil? Okay, so we are saying, hey, get the instance, and at any point it will say if the instance is not nil. Is there anything about the mutex that I'm missing? Let's see. We'll go to Go Packages, Sync Package, which is part of the standard library. We go to mutex. A mutex is a mutual exclusion lock. The zero value for a mutex is an unlocked mutex. Okay, a mutex must not be copied after first use. In the terminology of the Go memory model, the nth call to unlock synchronized before the nth call to lock for any... Okay, that's fine. We don't even really care about that right now. So lock locks M. If the lock is already in use, the call and go routine blocks until the mutex is available. And unlocks M in the runtime error if it's not locked on the entry to unlock. Locked mutex is not associated with a particular go routine. It is allowed for one go routine to lock a mutex and then arrange for another go routine to unlock it. So a mutex is not actually linked to a go routine. There is no connection, right? So you can lock it from one routine and unlock it from another. Great. So now let's look into our code for a second. So we're creating a lock, right? This package has a lock now and an instance. And we check if the instance is not empty, we return that instance. But what happens though is like it checks, hey, is this instance not empty? And it says, well, actually it is empty. And if it is empty, then I want to lock it. Then I want to call the repository. Then I want to assign the instance equal this new repo. Then I want to unlock, right? So there's no state in between that should be able to happen. So it's either it already exists and I return it, or it doesn't exist and I execute this as one unit of work. Meaning that I lock it, get my repository, assign it to it, interesting. I'm just trying to see why this is not, like, how come is it possibly returning nil? Because mind you, there is no panics that's happening here, right? So if the panic doesn't happen here, and let's just do this and error, right? But I'm pretty sure it will never reach this point. But I also can't really understand why it would return another. So what triggers it to return a nil? Okay, so here if repo. Of course I can use my debugger, but like I'm trying to figure this out from here, and again it is failing there, but it's not getting the panic. So now it's not getting nil, but it's 1 second, go clean cache. Go help best. And we're gonna grep for the word dash I for case insensitive dash. In package list mode only, go test caches successfully. Packages test. Results of a test can be recovered from a cache. Alright, so let's think about this a bit more. Well, what about this, right? So my understanding of the lock, though, is that something has to happen atomically, meaning that it cannot stop it in the middle, right? The only way I see nil is being returned as nil is that something checks and it says, actually, I am nil, so it ignores this here. It goes, creates the repo, it assigns an instance, this pauses, it goes back, and then it says, oh, you know what? I'm not nil. No, that doesn't make sense. Well, actually, 1 second now. if I'm running from different Go routines. Right. Time to do this, which is here. And bam, bam. Oh, of course it only ran it once. Okay, so we wait group, goes into another Go routine, then it calls wait. Step over, step over, step over, step into, step into, step into. So here, this is this, and this is the different instance. All right, let's do something. Is GoLang utext atomic. Let's look into something here. So now if let's stop this. Here, want will be nil, got will be nil. We're gonna say the wait group will wait for it. And here we'll run the get instance. So want would be like instance is not empty, it will return that. Then we goes here. Let's say even it stops in the middle of here, so it didn't finish here. Then it goes to add, it goes to get instance. It says, well, if the other one was not nil, then already exists should barely be the same thing here. the problem happens if I lock this whole thing. I don't know if that makes any difference because that would have been fixed by the deferrer, right? So that's not the issue here. So is it possibly the new? So if the and same here for want. I would just want to do it within the wait group. I want to see if the issue is occurring from that point. And again, still no panics. You know what? I want to do this. I'm gonna remove the counter, don't worry, but here's what I want to do. And I want this to happen. Also new lines. So, so the excuse me. So the counter actually got called 200 times, right? Because we're calling it twice. Okay. I want to go to the failed one and see what has happened there. Sorry, let me do this. I can just fail. That's interesting. You see how in every case it's like instance exists, or like do we ever get to that point when you instance? Yeah, right. So you'll find created, assigned. So this is a full test, right? But here you're getting the assigned before the created. And that is because the I just think it has to do with the printing order of the screen. It actually doesn't have anything to do with the exact order, right? Because writing to standard out will also have its own asynchronicity too. So the new instance assigned, created, instance exists, assigned, created. It's almost like the assigned always prints before they created. So if this here acquires the lock, then this tries to come. Okay, it will register, but then it should go to sleep. So for example, if I ever do this, like would we ever get the nil situation? right? So that kind of proves a point right here. Is like, if we're giving it a default value, it is kind of like picking that default value. And what is the default value for a pointer? It's a null. So something happened here where one Go routine would run and one of them wouldn't get to run, even though we're waiting for it, right? So let me try to do something here. Let's see if that fixes it. Add to. And now something is definitely blocking the whole thing. So we have somehow managed to create a deadlock. Hello, hello. So we've managed to create a deadlock. Now I'm trying to find out, where does that deadlock exist? So here we're having two different instances, but that's actually truly two different instances. This is not a nil anymore, right? So if we go back here, let's remove these print statements. We no longer need them. And we say if the instance is not nil, we will return the instance. Otherwise, we lock. And now that we're inside the lock, we'll create a repository using the new repo. And we'll assign this instance. Then we unlock. Then we'll return this instance. So now the question is, if we're returning that instance and it is assigned, how could it possibly be that the other one is a different one? So if the instance is not empty, so it's not nil, this means that this point has been assigned and it can never run half of that point. So it cannot like just reassign this here, but it's still like, it cannot jump like that because of the lock, right? But now we're at least getting legit instances, not like the nil value that we were facing before. By the way, I know a way where I can like look out how to get out of this fairly easily, but I'll show it to you after, because now we need to kind of figure out what's going on, because that's a concurrency issue. Hello, hello. Right. So we're adding to the wait group. It goes to Neo4j instance. Now let's try just doing the whole operation as atomic for a second. Let's see if that makes any difference. Let's run it 1000 times, 2000 times. Okay, so somehow making it like that makes a difference. But how could it be possible that the instance is not nil? So this works, but this doesn't, right? So the first time this runs, this must have been nil, and it will assign it a value, and then it will return. Would it be possible that right before the return statement, it kind of stops, so it returns? No, how come? Because we lock it here, we have the repo, we assign it to the instance, we unlock. At that point, instance regardless has been assigned something. And the second roundabout, I'm not really sure how is it possible that it could have been getting a different value. Like, you see two different instances here. Not cool. Create the repo. And I'm just so surprised because there's typically no, it shouldn't, at least, within the lock, this cannot execute without holding the lock. And if the lock is held, then nothing can interrupt these two operations right now. These are just happening as a unit, right? So in what way could these want and got get different values? Right, because again, we just saw that if we reorder the locking, it works. So what I'm trying to understand, well, actually, you know what? This would be a perfect thing to model here. So we can do, give me a circle. So in instance, let's try to think about that. Right? and we have routine 1, routine 2, and let's make these guys green, no fill. Kind of like that. Right. So if this here requests an instance first, then this will be null and it will go through this piece of code, right? And with this, let me okay, so here we have no, I'm just using a regular lock. So here is my my regular mutex. We don't need this anymore. Just sync mutex, right? Should I be using the read-write lock? Can you elaborate why? So you're saying this should work, right? But it is still failing the same thing, right? So what I'm trying to figure out is why, though, is even if I'm like using a regular mutex, here's the problem, right? If I do that order, so this makes the entire method essentially as lockable, and that works fine. But if I only lock and unlock here, then that doesn't work. And that's kind of like what's confusing to me, because the instance is not nil, doesn't need to be locked, because everything else will always be locked. So that's what's a bit confusing. All right, so let's do something. Let me show you an implementation of this instance, and maybe that gives us an insight. So if you go to GoLang singleton, here we have like a very good code example, right? And here how they're doing it is like they're having, oh wait a minute, is that why? Yeah, no. Okay, so they have a lock here, which is a mutex, and the single instance, which is our instance in that case. And they're saying if the instance is equal to null, you're gonna lock it, and then you defer. Then you do double checking. Single instance is equal to null. I don't like that double checking. Okay, so why are they double checking? So if it is nil, they would acquire a lock, maybe right before acquiring the lock. Oh, okay, I see. So maybe right here, it actually has changed, right? Let's apply the same logic to ours. So if we go, if instance is not nil, it says actually no, I'm nil, but the other go routine goes and it says, okay, I'm gonna do a lock. Here you go. That works in a very strange way by like looking at someone else's code and like reasoning about it, and then suddenly you're like, oh shit, it makes sense. So now, rather than doing a double check here, I can just lock the entire operation, and this would guarantee that here I cannot even pause in the middle. All right, okay, so I get it now. Because when you're in concurrent, right before you call the lock, you can, in theory, stop anywhere. When we had this approach, what could have happened, well, what must have happened, is that you go and you say, if instance isn't empty, well, it says, actually, you know what, I am empty. And then it goes to the lock, but right before acquiring the lock, that go routine stops, and another one goes, and it says, hey, is instance empty? It says, actually, yes, I'm empty. So it goes to the log, but now it acquires the lock, and now it creates the repo, and now the instance is assigned something, and then it unlocks. Now the go routine right before it goes back and it already stopped like right before here, right? So it's kind of like stopped. You can say stopped here. And if it stopped here, it will go and will acquire a log or create a new repo, and that's why we see two repos of different value. And that's why we can just simply log the whole operation. So this whole operation is atomic. And now it actually does work. Okay, well, the reason why I wanted to take some time with this, like we've done this like 20 minutes ago where we figured out that this works, but we didn't fully, at least I didn't fully click why it wasn't working. And for me, that is unacceptable, right? Like we have to know why the code is working and we have to know why it's not working. And that for me sounds like a reasonable analysis that we made, that I'm like, okay, I feel satisfied that I knew why one way wasn't working over the other. So now if we ever run into an issue similar to that, we know how it works. Locks for writes and allows any number of reads. Right, but when I used, when you suggested read write lock and we did read write lock, it had to do with the ordering as well, right? Or are you saying that read write locks will lock only for writes and allow any number of reads? I'm just trying to think here of like, let's take your approach and try it out, right? Like if we do read write mutex here, this, then you're saying it would only lock in that situation only, and any other situation it wouldn't lock because it's already just a read, right? And you're saying, but you still agree with me that the order of this matters. Like if we put it back to the previous order, it still wouldn't work, correct? So if we do that, I guess differ here is fine. Right? You see here that it still fails. And I think it's because the same situation. Let's go to the Go package and see the read-write lock. Thank you for suggesting it too, by the way. Yeah, go ahead. To acquire a read lock until the initial read lock is released. You need to I see. So you're saying we'll have to use different types of lock then, right? You're saying there's I see, the R lock and unlock. Got it. And here you'd do something like this. So is this kind of like the example of how to use read-write lock? But is there any real benefit of doing this right now than just like using a simple atomic lock like what we did earlier, where we just like use a regular lock? Right, I see. Okay. Got it. So I guess like situations where we'd use read-write lock is like if you have an expensive read operation, right? Something that's, for example, not fair enough. But thank you for suggesting that. Also, this is amazing that I'm literally learning from you guys as well. That's wonderful. Thank you. All right, so now that we kinda were able to fix our test and we're able to create a singleton, and we talked a bit about coroutines, and we're able to refactor the save document here. Now I wanted to talk about how I learned about some of the design patterns, right? So this was one of the books that I read. And this one is for reading cache. Yeah, right. So it's mostly when like the IO is expensive, that's where you would use read-write locks, because otherwise you're locking for things that could be served immediately. Got it. So heads first design pattern, I totally recommend it. Very good to like learn about even conceptually the design patterns, so it doesn't fully translate 101 to Go, just because Go is a bit different. It's not like fully OOP in the same sense as like Java is, for example. So you'll still need to do a bit of like a different way of implementing the patterns, but you will learn shit ton from it. So I totally recommend it, right? All right, now let's get back to implementing actually no, one second. For the saved document, we skipped one important aspect, right? And that is we are saving a document, but we're not associating it with any users. And for the users, we don't really have any users model right now yet. So we haven't really talked about how a user is gonna be implemented, right? but we know conceptually from the graph that like we're gonna have I don't know if we created any users. I think we did. So here is me, that's the user, and a user should also have a UUID. So our user here doesn't have a UUID, but once we have it in code, the user should have a UUID, and that's how you're gonna reference a user. And one way to do that is to actually inject it in the session. So for example, you can say user ID exists, and you can say like context dot value user ID, right? And you can say, for example, it's a string. Actually, you can call this as string. If it isn't string, you can return an error. Okay, and then you have access to the user ID. So you can like, right? So right now, our user ID will actually be empty because we don't pass anything to the context, and that's something that you want to validate. And here we have again like a choice to make. Do we want the user ID to be part of the context, or do you want to explicitly pass it to the save document, right? Remember that many operations on the repository will actually require that the user ID is available. And it's really up to you how you decide to pass it. If you pass it through a context, it might be a very valuable thing for you to do, because from the request downwards, like for once we implement the API side of things and you go downwards, you will be able to pass along the context. But like, let me show you an example. We don't have to run this anymore. I think we're very satisfied with the Neo4j repo test. We can get back to the saved document. Right, and we're not getting a string because we're actually not getting any value at all. So assuming here I add context, with value, and the key is user ID, and the value is like OpenMD, for example. Right, you see, there's the user ID OpenMD. And of course, you're not gonna pass it from the save document, which brings us to the second point. Most operations for the repository, you'll actually need to pass a context explicitly. And that is generally what the GoLang what is it called? Being like the proper way, or like what most Go people recommend, right? So you can say context, right? But now, of course, you broke the interface, and we will have to fix that because you don't really break the interface, right? Okay, so now if I go to my even Neo4j repository and I look into my repository definition, we're not really passing context. Great, but now our in-memory repo has been broken because we're not passing the context, and we'll do the same thing. Here, context. We're not really using it for the in-memory repo, but that's okay. Now we should run just like regular Go tests. Right, so I didn't have in-memory repo test, I guess. Right, I'm only testing that. We used to have a test for the in-memory repo. I guess we just kind of like moved it to the Neo4j. That's fine. But now, again, let's run all the tests. The integration even. Right, so now we're getting an error where Neo4j repository, line 42. Of course, because we're not passing the context to the saved document. So here, this is where you create a context. Context with value, and I can create, like, for example, timeout context. It's on dot milliseconds. So that's kind of like called context stacking, right? So here you actually like stacking a context and you're adding and extending more functionality to it. Here I'm gonna add the user ID and I'm gonna call it omembe, right? But I just wanted to see something, right? Is that now there is hidden data being passed around, and that's really my problem with the context, right? Is here yeah, right, the get document, it's the same context that I want to pass. Okay, and what else? Repository test. Line 44. What's happening? Assignment mismatch, one variable, but context with timeout returns two values, right? Which is the cancellation, correct? Yeah, the cancel function. Cancel func. And you can call defer cancel func. What else now? Line 47. Not enough arguments in call repo.save document. Oh, I thought I passed the context. Right. You see? Here, we get it back. So context stacking is very powerful, but my problem with it is that you end up losing visibility of what's coming in, right? So you're having this user ID, which is okay, great, but where did I get that from? So if someone is reading your code and it goes like, oh, okay, I'm getting it from context, but really where am I passing it? You would have to like search maybe for context with value, and it would be a bit hard, or like search for the keyword user ID, and that will be a very common context like keyword, or like a keyword to be there. So another approach is of course to like pass like the user ID explicitly, right? And you can just straight up use it, and you don't even have to do like type checking or anything like that. And a third approach is that whenever you're creating a document, you associate it with a user ID. That actually might be a very good thing to do, right? Because now it kind of like your actual model does model like your graph. So a document has an ID, has a user ID, it has a name, it has a document, but when it comes to like Neo4j, you're actually linking them with like a Neo4j link, but your data model doesn't know that you're using Neo4j, but now it's represented very good, right? But now when you're creating a new document, you'll have to pass the user ID here. I will pause on that. Next time, oh shoot. Yeah, next time we will implement it using the user ID in the document and refactoring this. So for now, I'm gonna delete this timeout context stuff. And I'm gonna get back without the context. So that should be fine. Repository, save document. Bye. Here context is equal context dot. Actually, let's use to do, because this simply signifies that we haven't thought about like timeouts and all that funny stuff just yet. And also the get document. Goodbye. And we can go back to the end memory repo, and we can just simply reset it. Bam, bam, bam. Good. Sweet. And now, of course, we need to reset this file too. Now, everything should run exactly the same. Of course, because we added this type checking here. It is unnecessary for now. And great, we get back to a failing test of having the document because we haven't implemented the get document. Next time, implementing the get document will be super easy. But just to recap, because this was a bit longer, we've talked about refactoring the saved document. We moved things around. We established a new repo. Oh, one last thing before we go. This now could be actually a private method, because get Neo4j instance will be the way we want our external folks to interact with our repository, right? So now we have something in the test that's referring to the new. Where is that coming from? This is coming from our repository to test, line 33. Right. Bam. Bam. Sweet, we're back to 0.1. But now there is one last issue here, is that the get instance is only returning the repo, and we're kind of like not using that error whatsoever, right? So one thing that we can do, of course, is that we do this, and here we return null, and here we actually get the error, return the error. But now, of course, again, our test, get Neo4j instance, it would return an error, and we can do that. And for every time we use get instance, I will define an error. It's becoming a bit more verbose, but you know what? At least we're not swallowing the error out of the blue, and we're respecting that if we are getting an error, we're going to report it to the user, but at the same time, we're not allowing the user to just use to construct a Neo4j repo at any other way other than using the get Neo4j instance. That way you lock in the singleton way of doing it. So again, we refactored the save document. We looked into how we do a singleton pattern. We talked a bit about testing concurrency, and we talked a bit about Go routines. We also learned about how to use, no, actually before this, we used wait groups and learned how to do wait groups. We also learned about locking and how to do locking, and the chat was extremely helpful and also pointed out that we can use read write lock. The case wasn't needed here, but it got it to our attention. It's something I didn't know about, so we all learned about that. And we talked about context and how we can use it to pass data down, but we've decided that next time we're going to implement it in the document side of things. So that's it for today, as usual. Thank you all for joining, and see you next time.